If we want to have an integer of exactly 32 bits, we can try to use int32 underscore t, and that type may be declared in this file. I say may because it's not guaranteed to exist. There are, for instance, digital signal processing environments where the CPU does not have a 32-bit register, instead 24 bits, and then it's impractical to have a 32-bit integer type. But almost always it's safe to assume for normal computers, so to speak, that there exist int 8, int 16, 32 and 64. And there is also the unsigned version of this with a u as a prefix. A question that arises is how we should print them. These two attempts are not portable. The first fails if, okay, I should say first, D is for printing a normal int, and LD is for printing a long int, or just long. And these two fails. The first fails if an int is 16 bits or something other than 32 bits, and the same if long is not 32 bits. So how should we do? What we need is some way to put the proper string here. And if we include int types, then we can use the following. This macro is a string, which is, well, it depends on what type this is corresponds to. I mean, this is a type def, and it's either int or long, or signed int or signed long. And so this, if it's a plain int, then this will be a string containing D. Now we can see that two strings are, next to each other. They are concatenated by the C preprocessor. So this will be just one string, and it will contain. Well, it will not be exactly that because there is a white space at the end, but that doesn't matter too much. Okay, so this will, this white space should not be there. And there is one for printf and one for scanf. They are both normally the string containing D, but it would be confusing to have a macro for scanning when we want to print, and vice versa.